For the first time in 40 years, the silicon architecture inside your personal computer is physically changing how it operates. This diagram shows the traditional PC model we've used for decades: a separate CPU, system RAM, and a discrete graphics card with its own VRAM. The RTX Spark consolidates these isolated parts into a single system on a chip, removing the physical distance between components. By shrinking the design, NVIDIA has placed a 20-core ARM processor and a Blackwell graphics engine onto the exact same piece of silicon. Usually, when you integrate a processor and a graphics card like this, the goal is to make the hardware more affordable. That is not the case here. With entry prices starting at $3,500, NVIDIA is positioning the Spark as a premium professional tool. The Spark shifts the focus away from budget-friendly integration and toward a goal of achieving high-density compute performance in a mobile form factor. The most significant advantage of this specific chip design is found in how it manages system memory. This chart highlights a common bottleneck. Standard laptops split memory between system RAM and a GPU pool, capped at 8 or 16 gigabytes. The Spark uses a unified architecture, sharing up to 128 gigabytes of memory across the entire chip at 300 gigabytes per second. This allows the machine to load 120 billion parameter AI models locally, tasks that previously required a dedicated data center to execute. Moving to an ARM instruction set also shortens the electrical transit distances, keeping total power draw between 45 and 80 watts. In practice, this delivers all-day battery life and ensures the laptop doesn't slow down the moment you unplug it from the wall. You are trading upgradability for that portability. The memory is soldered directly to the silicon, and that density drives the manufacturing costs to record highs. While the Blackwell engine is powerful, we need to distinguish between marketing expectations and the actual gaming performance inside a laptop chassis. This table compares the specs. The 80-watt power limit makes the Spark equivalent to a mobile RTX 5070, not a desktop card. As the data shows, it still delivers a high-end experience, utilizing DLSS to maintain over 100 frames per second at 1440p. The primary obstacle for gamers isn't the graphics power, it's the fact that most PC games were written for x86 processors, not ARM. To run your existing library, the Spark has to translate that software code in real time using Microsoft's Prism emulator. This translation creates a processing overhead. Expect slightly lower frame rates than equivalent Intel or AMD systems. Until developers start coding games natively for this architecture, gamers will effectively be paying a performance tax to use this hardware. The physical silicon acts as a delivery mechanism for a structural change in the way software functions. NVIDIA is moving toward an agentic PC model. This shifts the computer from a passive tool that reacts to your inputs into an active partner that can act on its own. Instead of opening apps manually, this decision tree shows the new workflow. Provide a natural language objective, and AI manages the tools. The NemoClaw framework routes your prompts to the most efficient local model, powered by the neural processor. Granting an AI agent autonomy to navigate the web and execute code introduces significant security risks. To counter this, NVIDIA uses OpenShell. It's a secure runtime environment that sandboxes the AI, ensuring your data is processed locally and never leaves the machine. Transitioning to this autonomous future requires software companies to adopt the NVIDIA Agent Toolkit. Without it, your existing apps won't be able to utilize these new capabilities. Because the RTX Spark changes the fundamental rules of PC design, its value depends entirely on what you do for a living. We can use this matrix to determine if the $4,000 investment makes sense for your specific situation. AI developers and data scientists land in the top right. Running 120 billion parameter models locally on CUDA allows these professionals to bypass expensive cloud subscriptions, making the high price a clear business asset. High-end 3D creators also see a high impact. This is the first machine to truly compete with the Apple M5 Max. It provides MacBook-level mobility and battery life while keeping CUDA support for 3D rendering. For hardcore gamers, the price justification is much lower. You can get better raw gaming performance for less money by sticking with Intel or AMD systems that don't have to deal with ARM emulation. Finally, we have mainstream users. If you mostly use your laptop for web browsing and office work, you should skip this. You don't need a $4,000 AI engine. The RTX Spark represents a calculated decision by NVIDIA to move beyond the traditional PC and create a new category of autonomous, high-density computing.